In section 7.6, you get to problems like numbers in the 19 range, and they ask you to find the maximum or minimum value of a function. Well, the vertex is going to be your maximum or minimum value. And so let's say you've got a graph and you've got a parabola that's opening up or something. The vertex would be the minimum there. And the minimum value is actually the y value of the vertex. If the parabola opened like downward, then the vertex would be the y value of the vertex would be the maximum. So what we kind of have to do here is find the vertex and then find the y value of the vertex, and that's going to be our maximum or minimum. So let's look at some of these. If you read the instructions, it says find the maximum or minimum value of each function and then give the coordinates of the vertex of the graph. Honestly, what you're going to have to do is find the vertex first and then tell that y value is your maximum or minimum. And so let's look at a few of these. I'll do several of these in case you're still struggling. Remember, we have 19 says g of x is 2x squared plus 8x. Now remember, g of x is this, we could just call it y if we like to, and one thing we can do to this equation is label it ax squared plus bx plus c. Alright, and the reason we do that, if you remember, I could complete the square to find the vertex, but I don't really want to do that much work, okay? I'm a little lazy. So what we usually do instead is use the little formula we learned back in Algebra 1. You can find the x coordinate of the vertex by using the little formula x is negative b over 2a. So if I look at this equation I have here, my a is a 2, it's positive 2. The fact that that is positive means this parabola is going to open up. If it were negative, it would open down. Since this parabola opens up, its vertex is going to be a minimum because it's going to be the low point. So I know that I'm going to have a minimum, and it's going to be the y value of the vertex, and they actually want me to say the vertex anyway, and actually I have to find it first before I can find that number, even though they asked you the other question first. All right, a is positive 2, so it opens up, and my b is 8. C would be 0 in this case, but if you look at the formula, I don't even need the c, so I'm not going to worry too much about it. All right, now if b is 8, let me put it in, and it's over 2a, a is 2, so that's negative 8 over 4, which is negative 2. So the x coordinate of my vertex is negative 2. Now that's not the minimum. We need the y value. How am I going to find the y value? I will just plug that x value into the equation. The equation up here was y equal 2x squared plus 8x. So if x is negative 2, it's 2 times negative 2 squared plus 8 times negative 2. You could type this in on your equation and then go to the table of values and find it, but I think it would take longer to do that than maybe to do this. Negative 2 squared is 4, so 2 times 4 would be 8, plus, I need to multiply these before I add, that's what PEMDAS tells us. 8 times negative 16 is, 8 times negative 2 is negative 16, so we have 8 plus negative 16 is negative 8. So my minimum is at negative 8. That is the y value of the vertex. So that's the complete answer for what they're asking you for there in 19. Let's try another one. 23, they give you this. And again, what they're playing around a little bit and just giving you quadratic equations in different forms. This one is in factored form. Some things I can do to kind of maybe make it make more sense to me. This is a y equal here. And really, if I want to do this, I'm going to have to multiply all this out. I'm going to have to distribute. So 2 times 5 is 10. 2 times x is 2x. Negative x times 5 is minus 5x. And negative x times x is negative x squared. So I'm going to put it in order from biggest exponent down to least. That would be negative x squared. For the x term, let me go ahead and add those two together. 2x minus 3x. 2x minus 5x is negative 3x. And then I have plus 10. Alright, so if I think about what we did on number 19, I'm going to find the vertex, and I'm going to write its coordinates down, and the y value of the vertex is either going to be a minimum or a maximum. Let's look at the a and the b and the c here on this equation. Remember, we can label this ax squared plus bx plus c. I really don't need the c, but I'll label it anyway. A is -1. There's an invisible 1 there. The coefficient of the x is the b term. It's -3. And then c is +10. And again, we don't really need the c because to find the vertex, that little equation is x. The x-coordinate of the vertex is x equal -b over 2a. It's that little first part of your quadratic formula. Okay. B is -3. Over 2a, a is -1. That's going to be a +3 over a -2, or -3/2. We could say -1.5 if we want to, but we always just tend to use fractions in Algebra 2. All right, now I got to find the y that goes with that. So I can plug it in, and again, you could go to your calculator and get this value if you wanted to. Here, I'll do it without the calculator. Minus x squared, so that's going to be -3/2 squared, minus 3 times -3/2 plus 10. Okay, so if you square -3/2, 3 squared is 9, 2 squared is 4, it'll be a +9/4, but then there's a negative out in front of it, so that's -9/4 plus 3 times 3 is 9 over 2 plus 10. Okay, let's get a common denominator with these two fractions. If I multiply this by 2 over 2, I'm going to get -9 over 4 plus 18 over 4 plus 10. And -9 over 4 plus 18 over 4 is 9 over 4 plus 10. And let's see, let me go ahead and just say that is, let's see, 9 over 4. 4 goes into 9 twice with 1 left over, so that's like 2 1/4 plus 10. And let's write this as a fraction. I guess if I write this as a fraction, I could have said that's 9 over 4 plus, let's see, 10, if I got a denominator of 4, would be 40 over 4. And that would be 49 over 4. Okay, so even your book gives the answer as 49 over 4. Now, is it a maximum or a minimum? Look at your A term, the leading coefficient, the coefficient of the largest term. It is negative. That means that this parabola is going to open downward, and its vertex is always right there in the middle. Well, that's going to be the highest point, so it's going to be the maximum. So here, our maximum value is the y-coordinate of that vertex, so it would be 49 over 4. And those, if you check, that's exactly what the book has for us there. Okay, for number 27, there's two like 20, you're supposed to do like this. One's 25, one's 27. I thought I'd pick 27 just because it needed some rearranging to get you started. They want the vertex, they want the domain, the range, and the zeros. So we'll work on those one thing at a time. Now, first of all, you think, okay, if I don't like looking at f of x, I can call it y. And another thing I know is that this is not in the right order. The x squared term is supposed to come first, and so it's got a -1 as its coefficient, so we'll write this as -1x squared minus 2x, and then there's a +8, so I'll put +8. That is standard form, and we need to write it in that form. Once I write it in that form, I remember that if I'm going to find the vertex, one thing I might want to do is label it, or think of it, in terms of ax squared plus bx plus c, because when I find the vertex, which is what they want in part A, I need the little equation x is -b over 2a. So if I think I've got to do that little equation, then I can remember to label it and pick off the a, b, and the c. The a here is -1. It's the coefficient right out front of that x squared term. The coefficient of the b term is -2. I really don't need my c, so I'm not going to write it down. Okay. So if I go plug those numbers in, -b is -2. Over 2 times a is -1. That would be a +2 over a -2, and that's a -1. Okay, that's my x-coordinate of my vertex. Let me write it up here, -1. To find the y-coordinate of the vertex, which will be a minimum or a maximum, I will plug that into the equation. So I'm just going to go take the equation the way I rewrote it, -1x squared, so there's my x squared, minus 2 times x, let me go ahead and plug in x is -1 there, plus c. Alright, that's -1 times, okay, -1 squared would be +1. A +1 times a -1 would be a -1. And then I go, okay, now I need to multiply these two things together. A negative 2 and a positive 1 is a positive 2. So I'll write a plus 2. And then plus 8. I don't know why I wrote a C there. It is the C, but I should have written an 8. So let me put a plus 8. Okay. Negative 1 plus 2 is 1 plus 8 is 9. So my vertex is negative 1, 9. By the way, this had a negative in front of it for the A term, so it's going to open down. So we're going to have a maximum at y equal 9. That's the y coordinate of the vertex. They didn't ask me to tell that, but I'll just go ahead and just mention it since we've been working on that in this section. Then they ask us to find the domain. All right. The domain of this, I can plug in any number I want to, and I'm fine. It's not like the reason I know that my domain is going to be any number I want it to be, which is all real numbers, which I can also write this way if I want to. The reason I know that, there's no square roots that I got to worry about in this. Remember, if you get something under a square root that's a negative, you got to watch that for your domain. And the other thing is there's not we don't have any variables, in the bottom of this. This is not it's not an equation that's a fraction with a variable in the denominator. So I can put in anything I want to. So it's going to be all real numbers. Now, the range though, what's going to help me find that? Well, look at this little sketch I made up here. If this y value of my vertex, it's going to be a maximum, isn't it? That means it's the highest value, the highest y value on the graph. That means that all my y values have to be less than or equal to 9. So that's my range. Y's are less than or equal to 9. And then one more question, find the zeros. I'm going to do that on a new sheet here. Running out of video, so I'll probably be cutting it off and on and just doing a lot of work and mentioning it. If I want to find the zeros, that means set y equal to 0 and solve it. Alright, but when I do that, if you remember, I can't really factor very well with a negative x squared, so let's factor a negative out of every term. That would make the negative x squared a positive x squared, the minus 2x a plus 2x, and the plus 8 a minus 8. Remember, when you factor out a negative, it just switches the signs on everything. Alright, so now I'm going to try to factor that. Hopefully it will factor. If it doesn't, I'm going to have to use the quadratic formula. Is there anything that multiplies to give me negative 8 and adds to give me 2? Well, yes. 4 times negative 2 would be negative 8, and 4 plus negative 2 is 2. And I'm thankful that factored because it's much, to me, easier to solve it that way. So we're going to have an x plus 4 and then an x minus 2. So our zeros are our x-intercepts, and they are the solutions to our equation. So I set each one of these little factors equal to 0. And so for this one, when you subtract 4 from each side, you'd get x equal negative 4. And this one, if I add 2 to both sides, I'd get x equal 2. So my zeros are my solutions, or my x-intercepts, or my roots, whatever I want to call them, happen at 2 and 4. That's supposed to be, negative 4, sorry. That's supposed to be fancy braces. Of course, I'm not that great at that with this stylus. And so there's our zeros. That's all the parts that they ask you to do there.